In this episode, we're going to unbox an engraving laser right here. Basically how it came. It comes with, it's a blue laser, comes with these green glasses, which probably are better for red lasers than for blue lasers, so I wouldn't use these to protect myself against a 2.5 watt laser. But anyway, you get some free laser goggles. And then let's show you the unit itself. So here it is in the box. It's open. And here it is. So this particular unit is sold with a pulse width modulated driver for the laser here. And you can see the integrated circuits on the back. And I guess the pulse width and frequency are adjustable via those two trimmers, but I'm not going to touch those. It looks like they've been sealed into a certain setting. And the actual laser module itself is in here. As you can see here, it's a class 4 laser, so that means it's a pretty high-powered laser and very dangerous to use without significant protection, eye protection. And it comes with a small fan, as you can see there. And they've actually connected up some of it, so it's got a fan power supply right there. This is the input wire right here, and what I'm going to do is use a buck converter, because it says that this thing needs a minimum of 2 amps, 2+ amps to run it. And most 12 volt wall adapters that you get are 1 amp or less. I'm going to use this laptop adapter. This is what I'm going to use. This thing can take in anything up to 30 volts and output anything down to 3 volts. So from 30 to 3 volts. So this is very useful. You just adjust that blue trimmer there to get your DC output. And I soldered the leads in place. And I've adjusted this to output 12 volts DC, and this can put out anything up to 3 amps, which is enough power to drive the laser driver. It looks like connecting it up is going to be a bit of an issue, but I've got this. So what I'm going to do is I'm going to plug this into that, then I'm going to plug that into this. So let's do that right now. I think that's going to hold. Now let's test it out. And before doing anything with any laser device, use some laser goggles. And I'm going to use these, and you can just see these ones are actually rated for blue lasers, which is what this is, and you can see how different those are from the ones that were supplied, which are these green glasses. So whatever you do, don't just put the glasses on that these companies will supply you. Make sure that it's the correct rating. And there's your wavelength. The OD7 that you see written there, OD is the attenuation factor, which is 10 to the 7. So this is going to reduce the light entering the glasses by 10 million times. So that's what that OD7 is. Okay, here I am burning. I've got a little design here on some cardboard. There you go. One thing I do notice, I did notice, is that the transistor is very hot. And I think this heatsink, this one's okay, this one's hot, warm, but this one's hot. So I think this heatsink is way too small. And this is for the MOSFET transistor that's present on this one on the left here. So I'm going to replace that with a bigger heatsink. So I'm going to use this. And then I should be able to get much longer run times with it, because I'm afraid that this is going to overheat and burn itself out. But there you are, first try. Now I'm going to try and burn a hole through a piece of thick card, and it looks like it's burnt right through it. So let's check it out. First I'll turn it off. right through and through. I do not have a laser output meter, so I can't really measure its output directly, but as you just saw burning through that card, definitely shows it's got a lot of power in it. And as I can't really modulate the output of this laser, I can modulate its ability to cut by using time. So if I draw it over an object such as a piece of wood, if I draw it slowly, then I should be able to cut deeper into the wood. I don't have a CNC cutter or anything like that, so everything I'm doing right now is manual, but one of the projects I do plan to do is come up with an Arduino-based machine and incorporating that into that machine. So what I need to do now is just replace the heatsink on that transistor, and then I should be ready for long runs. I went a step further here and used an even larger heatsink because I just think that's pretty important with the amount of heating I was getting. So I've got a big heatsink. This is actually salvaged out of an old computer motherboard. And what I've done is I've basically screwed everything down to a piece of polycarbonate plastic. So this is Lexan plastic. So I've got my buck converter here, set at 12 volts. Here's my connector. Here's the laser driver on standoffs, and I've mounted the heatsink onto that transistor with plenty of thermal paste, and hot glued everything in place, and also use a zip tie. So this is a combination of zip ties, hot glue, and standoffs. And there's the laser module. So it's all set, and I'm going to give it a quick test run, and then I'm actually going to try and cut a piece of wood with it for this test run. So let's try it out. Here's a piece of wood, and we're going to try and burn through that wood. The following are screenshots of where you can get this laser module, as well as the step down or step up, step down boost converter. Thanks for watching, and please don't forget to sub.